Welcome back. Today we're going to start a conversation about arithmetic sequences. So this entire chapter is all about sequences, and this one is starting with arithmetic. Now, what I mean when I use the term arithmetic, that means that we are adding the same thing every time to get to our next term. So in this example, we're adding 3 to every term. 3 plus 3 gives me 6, plus 3 gives me 9, plus 3 gives me 12, plus 3 gives me 15. So that's what's telling me that this is arithmetic, that I have that common difference. I'm adding the same thing every time. And so what I want you to notice here in the second one, this is not arithmetic because you're not adding the same thing. You're adding 2 to get to the second term, adding 4 to get to the next term, adding 8 to get to the next term. So that one clearly not arithmetic. All right, so that's how you can tell the difference. Just see what are you adding. If it's consistent, if it's constant, it's arithmetic. If it's not constant, then it's not arithmetic. All right, so remember, there's two ways we can write these formulas. There's the recursive definition. The recursive definition, remember, has two pieces. First, you have to identify what the first term actually is. Okay? So you have to say what that first term is. Then, you have to say what's happening to that term. So I'm going to take my previous term, that's what that means, my previous term, and add that difference to it. So for this case up here, what you would do is say A1 is 3, and what am I doing to every term? Well, I'm taking the previous term and I'm adding 3 to it. So the recursive formula is as simple as that. All you have to do is label your first term and then what's happening from there. What are you adding to get to your next term? Now, while the recursive formula is nice when you're dealing just with a couple of terms at the beginning of a sequence, what's more useful is usually the explicit. And what the explicit is useful for is when you get it, you can find any term of the sequence. So for the explicit, you're taking your first term, adding n minus 1. Now here, your n, think of as your variable. Think of n as your x in these formulas. And d, what is my difference that I'm adding? Well, I'm adding 3 every time. So what am I going to do? Well, you can distribute that 3. So you get 3n minus 3. Those 3's cancel. So you get an equals 3 times n. And so with the explicit, all you have to do to find any given terms, if I want the 10th term, I just plug 10 in there and get that it's 30. So that's why the explicit formula is really nice, and that's the one we're going to end up using most commonly throughout this chapter. Now, let's get a little more practice at this. So, for each of the following arithmetic sequences, write the recursive formula, the explicit formula, and then use the explicit formula to find the indicated term. So, the first thing we have to do is find what are we adding every time to go from term to term. 5 plus 6 will give me 11, plus 6 will give me 17. Plus 6 will get me 23, so on and so forth. So that D this time, that D is going to be 6. That's what I'm adding to generate this sequence. So recursively, remember recursively, I need to indicate what my first term is, and then I say what any term is based on the previous term, and in this case, I'm just adding 6 to it. I think a recursive list, all you have to do is very, very simple to write. For the explicit, Now I'm going to write this up here to remind you. The explicit, you just have to plug in the pieces, and that's the generic formula for the explicit. So I plug in A1, so A1 is 5. That n is my variable, it's like my x, so I don't want to do anything with that. In my d, what am I adding? Well, I'm adding 6. And then you always want to simplify this. So you always want to distribute that 6, 6n minus 6, and then you want to combine your like terms. So I'm going to have 6n, then 5 minus 6 is a minus 1. And that's going to be my explicit formula. Notice how it looks just like the equation of a line. That's why I want to write it this way. And if I want my 100th term, all I have to do is plug in 100. 600 minus 1 is going to be 599. And then I'm finished. Well, let's take a look at this one. So this time, to go from term to term, it looks like I'm adding 2. So my n, or my d this time, is going to be 2. So recursively, all I have to do is I have to note what that first term is. And then I state that for any term, I'm going to take the previous term, and I'm adding 2 to that. And again, that's it recursively. That's all I have to do. Explicit, I have to plug in the numbers. So A1 is 3 plus, then again, always leave that n minus 1. That n is like your variable. And this time my d, that common difference I'm adding, is going to be a 2. So to clean this up a little bit, I'm going to distribute that 2. So I get 3 plus 2n minus 2. And I combine my like terms. So 3 minus 2 is going to leave me a positive 1. And once I have my explicit formula, now I can use it to find any term. So if I want the 46th term, I get that. And 2 times 46 plus 1, if you type it into your calculator, you get 93 as your 46th term. All right, one last one that I want to show you. So for this one, notice I've been saying that you're adding the same thing every time, but adding and subtraction go hand in hand. So arithmetic also includes when you're subtracting the same thing every time. So in this case, I'm subtracting 3 from every term. That is also arithmetic. So recursively, I need to identify what is my first term, and then I have to state that to every previous, or for every term, I take its previous term, and I'm subtracting 3 from it. Explicitly, I just have to plug everything in. So my first term plus n minus 1, because n is like my variable, and my d is negative 3. So to clean this up, I'm going to distribute the negative 3. Now be careful here, negative 3 times negative 1 is a positive 3. So I go to combine my like terms, 5 plus 3 gives me 8. And if I want to use that to find a future term, Negative 3 times 35 plus 8. Just plug it into my explicit formula. And that is going to give me a negative 97 for my 35th term. So that's the basics you need to know to begin our conversation about arithmetic sequences. Just know how to write both of the formulas and use the explicit formula to calculate a term.